Assalamualaikum and selamat sejahtera. We will start the discussion using a simulation work. In this simulation, I will show you the difference between uncontrolled and controlled half-wave rectifiers with inductive load. As usual, based on the inductive load characteristics, we will focus on the wave shape of current waveforms. For this simulation, the firing angle of the control rectifier is set to 45 degrees. Then, the output voltage and current waveforms of the uncontrolled rectifier will be connected to the second axis of the scope, while for the control rectifier, it will be connected to the last axis of the scope. As we can see here, the current waveform of both rectifiers have some similarities. First, when we focus on the starting time, we can see that the currents are slowly increasing from zero value to energize the inductor. Second, we focus on the time in which the current conduction halts. Based on the graph, we can see that both currents will stop flowing in the circuit when the time is beyond 0.01 second, which equivalent to pi. And this time actually is referring to the extinction angle value. However, we can see from the graph that the starting time of each current conduction is different. In the uncontrolled rectifier, the starting time starts at t equal to 0, while for the control rectifier, it started beyond 0, where this time is referring to the time where the control signal is applied to the rectifier. And this time is equivalent to the firing angle. Nevertheless, regardless of the difference in the starting time, we can see that the current conduction has caused the output voltage waveform of both rectifiers extended until the extinction angle. However, when we compare the average output voltage, we can see that the control rectifier has lower voltage value than the uncontrolled rectifier. Moreover, in supplying the inductive loads, we can see that only the output voltage waveform is being chopped at the firing angle. Next, let's look at what will happen to the extinction angle when the impedance value increases. So this is the simulation result before I change the load. Now I will run the simulation again. As we can see here, the extinction angle increases along with the impedance angle. Hence, it verifies the relationship between the impedance value and the extinction angle that we have discussed in the previous topics. Lastly, as similar as we did to the uncontrolled rectifier, we can increase the average output voltage of the control rectifiers by using a freewheeling diode.